Hey mathematicians, welcome back. We're going to do a review of factoring from Algebra 1. We're going to do it all in one lesson instead of babying you. We're going to make sure that we get through all of it today. So this is lesson 4.3 and 4.4, factoring quadratic polynomials. So just a little background, we factor because when we have the factors, we can actually solve for where the quadratic function hits the x-axis. And we're going to do that later in this problem. Before we can factor, we have to check for a greatest common factor first. We have to see if there's something we can take out, because if we don't, it's going to disappear, and we're actually going to have an incorrect answer. So first we're going to check and see if there's a number that every number in the problem can be divided by. Then after we check for that, we decide if the polynomial has a leading coefficient of 1 or not. These notes, we're going to do it all with asterisk method. We'll show you that here in a minute. But first, let's talk about greatest common factor. So on this problem, it's about finding the largest number that both of these things can be divided by. And on 36 and 48 both, we notice that I could divide them both by 12. If I divide 36 by 12, I get 3. If I divide 48 by 12, I get 4. And 3 and 4 don't have anything in common. So in that case, the greatest common factor is 12. It can also be a case where one of the numbers themselves is the greatest common factor, as is the case in number 2. In number 2, the largest number 6 and 144 can both be divided by is 6. And then we've got other cases where there's not a greatest common factor. 17 can only be divided by 17 and 1. And so the greatest common factor, we wouldn't pull it out because there's no sense in dividing everything by 1. But the greatest common factor in that problem is 1. So we know two things multiplied together to get this problem. And I know that if I do what I said I was going to do, I need to divide everything by the greatest common factor first. And this problem does have a greatest common factor. Everything in this problem can be divided by 2. So when we divide everything by 2, we get a new equation with 2 times 12x squared. 2 times negative 10, or 2 times negative 5, right? That's what would give us negative 10. And negative 4 would be negative 2 now after getting divided by 2. And we know from the past that the number in front of x squared is a, in front of x is b, and the constant is c for constant. And that's going to be important because what we're doing with the asterisk method is we're going to put these numbers into a formula that's going to help us figure out what the numbers would be on the two multiplied factors. So if I do this right, I put a times c up top, I put a in the sides, I put b in the bottom, and then these are the numbers I'm trying to find. What I'm trying to find is which two numbers multiply. That's supposed to be a times sign. But they multiply to get the number on top, and we add those same two numbers and get the number on the bottom. And we're going to see that in this problem we're about to do. If I draw my asterisk, I put a times c up top, which is negative 24. I put a in the sides, which is 12. And I put b in the bottom, which is negative 5. And our goal, again, is to see what two numbers multiply to get negative 24 and add up to negative 5. The easiest way for me, if I don't just know this off the top of my head, I list the factors. I'll do 1 and 24, 2 and 12, 3 and 8, 4 and 6. And you might be going, Mr. Lambright, it's actually negative 24. And that's true, and that means that one of these two numbers, one of them, has to be negative. Well, the only ones that have a difference of 5 between them are 3 and 8. And for that difference to be negative, the negative has to be on the larger number. So we know our two numbers are 3 and negative 8. So that's a start, but there's a couple of other things we have to do before we can actually finish this problem. Because we know that when we factor it, it's going to be something x plus or minus something And there's going to be 2 of those. So our next step is to reduce these 2 fractions, because this is a fraction, right? We're going to reduce them if we can. These 2 both divide by 3, so that's going to be 4 over 1, which is now reduced. These 2 both divide by 4, which is going to be 3 over negative 2, which is reduced. So now that we are looking at those as fractions, we take the top number and put it in front of x. So 4x, and the bottom number was positive 1, so plus 1. And then our second one, 3x, bottom number was negative 2, so minus 2. 4x plus 1, 3x minus 2. And then we finally have to put the number that we factored out in front, and we get our final answer. So it is a little messy. It does take a little while to get used to this, but now we know that these are the 2 factors that when multiplied gave us 12x squared minus 5x minus 2, and then if we doubled it all, we would get back to the 24x squared minus 10x minus 4. So don't worry, we've got several more examples of this coming up. Want to make sure that we get this all straight in our heads. So a is 1 in this problem because a is missing, and we want to know, does this work when a equals 1? So there's nothing to factor out because 1 is the leading coefficient, 1's the number in front. So I can't divide by anything because 1 is the biggest thing I could divide by. And then a times c goes up top. 1 times, wow, I just wrote a everywhere. I'm not going back. I apologize. That should be b. That should be c. I'm not editing this video. Sorry. A times c goes up top, so we do 1 times negative 32, which is negative 32. And on the bottom, we put b, which is negative 4. And again, we have to ask ourselves the question, what things multiply to get negative 32, and those same numbers add up to negative 4? So if I don't know, again, you don't have to do this if you can figure this out already, but I'll list the factors of 32, and that's it. Well, the only ones that have a, because it's negative, the only ones that have a difference of 4 is 4 and 8. And because the 4 is negative, the larger number has to be the negative one. We have 4, we have negative 8. And when I say, does the asterisk method work when a equals 1? Yeah, it does. There's just nothing to reduce. These fractions are reduced. So we are going to do 1x plus 4 and 1x minus 8. It's actually a little easier because some of the steps don't have to happen. The problem is done for us. Now, these are a little weirder because something's missing, and the answer is it's the x term. B is missing. So when you have a problem where there's no middle term, b equals 0. So when I've got a problem here, let's see, I have a is 1, c is negative 16, and b is 0. So we're going to punch that in. A is 1, a times c is negative 16, b is 0. I need things that multiply to get negative 16. The same 2 numbers add up to 0. And the only way that works is because 16 times itself, we do the 4 and the negative 4. That gives us multiplied negative 16. Added together gives us 0. And we learned already that when a is 1, we don't have to reduce because there's nothing to reduce. And that would be our answer for that problem. For the next one, we do have a greatest common factor to take out. Both of these can be divided by 2, so we're really doing the problem x squared minus 9. And that means a is 1, c is negative 9, and b is 0 again. We'll go back to the asterisk. 1's here, 0 here. A times c, 1 times negative 9. Must be 3 and negative 3. The 2 comes down, and we do x plus 3 times x minus 3. And that's it. Because once again, it was easy to think of what multiplies to get negative 9, but adds up to 0 because it's a perfect square. And we're going to do this one more time. This time a is 9, c is negative 4, but b is 0 again. So we got 9, a times c is negative 36. So we need things that multiply to get negative 36 but add up to 0, and that would be 6 and negative 6. We are going to have stuff to reduce this time. These reduced by 3, so 3 and positive 2. These reduced by 3, so 3 and negative 2. And that will become the parentheses 3x plus 2, 3x minus 2. So we just put the numbers, the first number in front of x, the second number following. That's how this goes. Again, that was really fast, so if you need to go back and rewatch or message your teacher, all of that is okay. If you're at home, I strongly recommend that you try these on your own first by pausing right now, and then here in about 10 seconds, I'm going to start doing these problems instead. If you didn't pause, here we go. We have a problem. We know we don't have a greatest common factor in the first one, so we don't have anything to divide out. That makes this a, negative 1 is b, and negative 2 is c. So a is 6, a times c is negative 12, 6 times negative 2. B is negative 1. I need factors of negative 12 that add up to negative 1. And that one comes to mind right away. Negative 4, positive 3. Looks like there is something to reduce out of both of these. These both reduce by 2. So we'll have 3 and negative 2. These both reduce by 3. So we will have 2 and 1. 3x minus 2, whoops, hit back instead, and then 2x plus 1. Same deal on the next one. We don't have a greatest common factor to pull out, so we can go straight to the labeling A, B, and C. Draw my asterisk. A is 2. A times C is 24. B is 11. We need two numbers that multiply to get 24 but add up to positive 11. And we get 8 and 3. This one is reduced already. This one reduces by 2. So we get 1 and 4. So x plus 4 and 2x plus 3. This problem is one of the ones where b equals 0 because the x term is gone. A is 4. C is negative 25. Plug that into the asterisk. Get negative 100 for 4 times negative 25. 4's in the sides. We need two numbers that multiply to get negative 100 and add up to 0, which is 10 and negative 10. Both of these reduce by 2, which leads us to 2x plus 5, 2x minus 5. Hopefully, if you were checking your work right now, you did okay, or you know what you did wrong. And we do have one more thing to hit. There's one little thing that's tacked on, because there's a point to all of this. There's a reason we do all of this. And that is so that we can solve for the x-intercepts. So we are going to do two problems. And we're going to, so we see that they're equal to 0. And we know there's something called the zero product property. When two numbers are multiplied times each other and they equal 0, one of them, or both of them, but at least one of them has to be 0. So when I solve the two factors, I'm going to know that I can set both of them equal to 0 to find the missing thing. So to start, we know in this problem we have a greatest common factor. So we're really dealing with 2. Once again, having connectivity issues with my stylus, but we're back. So that 2 is times 2x squared minus 4x plus 3. Still equals 0, so we are going to go ahead and do the asterisk method. A, B, and C. I'm going to do this over here. We're actually going to need a little more room than I thought. That is the ugliest asterisk. It'll work. So we're doing the 1s here. 1 times 3 is 3. We got negative 4 down here. This one might trick some people, but one way to get a positive number by multiplying on top is with 2 negative numbers. So we could do negative 1 and negative 3 times each other is positive 3. Added together is negative 4. So we have, if I write this at the end, they're both reduced. So we have x minus 1 and x minus 3. And then x minus 1, so because the last step is to set them both equal to 0 and solve. X minus 1 equals 0, x minus 3 equals 0. That's what this extra part is. To solve, x equals 1 and x equals 3. So x equals 1 or x equals 3. Those are the two places, x value of 1 and x value of 3, where this particular quadratic function is going to hit the x-axis. That's the whole point. We're looking for the x-intercepts or the roots or the zeros. Those are the different words for it. Same deal here. We don't have anything to factor out, so we've got a, b, and c. That's 1, 6, negative 5. Looks like negative 2 times negative 3 would give us positive 6, but add up to negative 5. We have the problem x minus 2 times x minus 3 equals 0. And that's going to lead us to doing x minus 2 equals 0, x minus 3 equals 0, which when I solve means this particular problem crosses the x-axis at an x value of 2 and an x value of 3. So it's not enough to just stop here because there's more to do, and sometimes it's not even as easy as that because there will be numbers on the x's. That is where we're going to stop today, though. Hopefully this was informative. I know we did a lot of examples, and I know we moved quickly, but there was a lot to see. We want to make sure we got through all of it. Please message your math teacher if you have any questions, and we will see you again in our next video.